Hello, my name is David. For this problem, we're given the function f of x is equal to 2 times x to the fourth power minus 6x squared plus 1. And they're asking us to graph this using our graphing utility and to find any real zeros and any relative minimums and maximums. So let's start by turning our graphing utility on, going to y equals, and just copying this function exactly the way it is into y sub 1. Now, after we have typed these numbers and variables in, we can click graph, and you'll see the graph of this function appear. Now, let's look for the zeros first. In order to find the zeros, we can go to second trace, which is also known as calc, scroll down to 0. And so from here, our graphing utility is going to ask us for left and right bounds. The reason a lot of graphing utilities do this is because if you look at the graph, this function crosses the horizontal x-axis 4 times, meaning there are 4 different zeros. And so in order for the graphing utility to not get confused, you need to specify to it which zero we're actually trying to find. Right? And so in order to specify, you want to put a left and a right bound to say this is the zero we're trying to find, and then this is the zero we're trying to find, this is the zero we're trying to find, and another left and right bounds for the last one. So we need to do this 4 separate times in order to find the 4 different zeros. Right? So we can start by finding the first one. You can just select any left bound that is to the left of the zero, and then any right bound that is to the right of the zero we're trying to find. This way we're able to target which zeros we're trying to find. And then we can approximate somewhere in between, which will now give us an exact answer. So now our graphing utility tells us that there is a zero at negative 1.680. And I'm just going to round to 3 decimal places for the sake of simplicity. And so now we can do it again to find the second zero. So again, we go to second trace, which is calc, scroll down to 0, and now we just need to pick another set of left and right bounds, but this time around the second zero we're trying to find. After we do that, the graphing utility is going to give us the next one, which is negative 0.421, right? Now let's do it again for the third one. Second trace, which is calc, go to 0. Pick a left bound that is a little bit to the left of the 0. Pick a right bound a little bit to the right of the 0. And then it will give us positive 0.421, right? Because this is a symmetrical function, it's going to be the same thing here. So we can already guess that the next one's probably going to be the positive version of this, right? But just to make sure, we can go to second trace, which is calc, scroll down to 0, pick a left and right bound around our final 0, and the graphing calculator will give us positive 1.680. Awesome. Okay, cool. So now let's find the relative minimums and maximums. Now to do this, it's actually very similar. We go to second trace, which is calc again, but now instead of going to 0, we go to minimum. And it's the same type of idea. We need to pick a left bound and a right bound for the minimums as well. The reason being, again, there are multiple minimums, right? And so in order to tell the calculator which one we're specifically trying to find, we need to be specific to it. So there is a minimum at negative 1.224, comma, negative 3.5. At these coordinates, we have a relative minimum. And now let's do the same thing. Go to second trace, which is calc, minimum, and repeat the same process to find the other relative minimum. And you'll see it's just simply the positive version of this. So it is positive 1.224, comma, negative 3.5. Because remember, this is still negative because it's below the horizontal x-axis. Awesome. Cool. And now to find the relative maximum, we do the same thing we did for the relative minimum and for the zeros, right? Except instead of clicking minimum or 0, we go to maximum. So we go second trace, which is calc, then we go to maximum, right? Pick a left bound and a right bound. And you'll see that the relative maximum is 0, 1. Now, one thing to note about using graphing utilities is that not all graphing utilities are the same. Some of them don't actually require you to find the left and right bound. Some of them are simple enough where you can just point at the exact 0 or minimum maximum that you're looking for, rather than using boundaries to specify which one you're looking for. And that is how we solve this problem. Thank you.